Hello everyone, welcome to another video for mathematics of grade 10. So in this video we are going to start chapter 8, which is all about trigonometry. The first section deals with definition and some basic concepts of trigonometric functions that we will cover all of them together, and I will define for you the three trig ratios that are the main concentrations of this chapter, and then we'll do some of the examples that shows us how we can use those concepts in real mathematical questions. So the first section is about solving right triangles. We'll start with definition of a right triangle. I will review for you the most important theorem that we have for right triangles, which is the well-known Pythagorean theorem. And then we'll move on to the trig ratios. Okay, so let's start. So first of all, here you have trigonometry. It's all about triangles. Well, of course, that's how it started, right? Many years ago, trigonometry started in triangles, especially in right triangles, and then found its way to some other areas in mathematics. So nowadays, we are using trigonometry in all areas in science, in physics, in engineering, as well as mathematics itself. So if you recall the definition of a right angle triangle, we say a triangle is a right triangle if it has one right angle. So that's the notation for 90-degree angle. That notation stands for right angle, which is 90 degrees. There are some definitions that you should know in a right triangle. So if I show this angle by theta, so theta is a Greek letter that usually we use for angles. So if we show this angle by theta, then the opposite side to this angle is called, well, no surprisingly, opposite. The side which is next to this angle is called adjacent. Adjacent means next to. It's like a fancy word to mean next to. And then the longest side in a right triangle, which is usually, which is always the side which is opposite to 90 degree, is called hypotenuse. So hypotenuse is the longest side in a right triangle, or the side which faces the 90-degree angle. It's called hypotenuse. So you should remember these names: opposite to this angle, adjacent to this angle, and hypotenuse. So notice here that hypotenuse is always fixed. In a right triangle, hypotenuse is always the longest side, but opposite and adjacent, they correspond to the angle that you choose. So if I choose this angle, then this side is opposite to this, and this side is adjacent to this one. But if I choose this angle, so if I choose, let's call this angle, I don't know, phi. Phi. This is another Greek letter. So if I show this angle by phi, now this side will be opposite to this angle, and this side will be adjacent to this angle. So opposite and adjacent, they are related to which angle you're picking and which angle you're using. All right. So let's see what are trig ratios. Suppose you have a right triangle like this one, and this angle theta. This one is opposite to this angle, adjacent, and the hypotenuse. Then I'm going to define three ratios in this right triangle. We call them trig ratios. So the first trig ratio that we're going to define is called sine. So sine of theta, sine of this angle, is defined to be the opposite length, the length of the opposite side, divided by the length of the hypotenuse. So in this particular example, you will see sine of theta is defined to be opposite over hypotenuse. It's a very important ratio that you should memorize. The other trig ratio that we have is cosine of theta. So cosine of the angle is defined to be adjacent, so the side next to the angle, divided by the hypotenuse. So cosine of theta is defined to be adjacent over hypotenuse. And then the last trig ratio that you have in this chapter is tangent of theta. We denote it by TAN, tangent of theta. This ratio is defined to be opposite over adjacent. So opposite over adjacent. So these are the main three trig ratios that we have in a right triangle. So you should revise this for yourself over and over again so that you can memorize these three trig ratios. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. So let's see how we can use these kind of ratios in a question. Let's see an example. So the question says find sine of 35 in the following triangle. So you see a right triangle here, and question says find sine of 35, sine of this angle. So what do we know about sine ratio? It is defined to be opposite divided by hypotenuse, right? So the opposite to this angle is this one, adjacent is this one, and hypotenuse is the longest side, which is always opposite to 90-degree angle. So let's write down the ratio for sine. Sine of this angle, 35 degrees, equals opposite over hypotenuse. Okay, so those are the abbreviations for opposite and hypotenuse. Let's replace the values. Opposite is given by 2.8 and hypotenuse is given by 4.9. And now if you divide these two numbers, you will get an answer which is approximately about 0.57. So 0.57, that's the value of sine of 35. So sine of 35 is 0.57. Let's extend this example and let's find the other trig ratios. Well, question says just find sine of 35, but I'm going to find the other trig ratios as well, cosine and tangent of 35. So let's see how the other ones are. I'm gonna write it over here. So cosine of 35 degrees equals, so remember what was the definition of cosine? It was adjacent, which is this one, divided by the hypotenuse, right? So adjacent over hypotenuse, so which is equal to, in this case, adjacent, in this example, adjacent is 4 and hypotenuse is 4.9, which is equal to 0.81. So that's the approximate answer. I just rounded, 0.81. Let's find tangent. So what is tangent of that angle? TAN of 35 degrees equals. So for tangent, the rule was opposite over adjacent. So opposite over adjacent equals. Opposite is given by 2.8, adjacent is 4. So if you divide these two numbers, you will get 0.7. And that's the value of tangent of 35. One thing that you should know about these trig ratios is that you can easily use a calculator and find the trig ratios for any angles. So if you look at your calculator, you will see sine, cosine, and tangent button on your calculators. So for example, if you want to find what is the sine of 35, just simply press 35 on your calculator and then press the sine button, and then the answer will be shown on the screen. On some calculators, first you have to press the sine button and then the angle. So depending on calculator, you can easily find out the trig ratios for any angle on your calculator. Alright, so let's see the next example. It says, how tall is the tree? So look at the shape here. You see a right triangle here. This side of this right triangle kind of represents the height of this tree. Okay, the height of this tree is the length of this side, which we are going to find it, right? Okay, so let's call that side x. I'm going to call this side x. And by the way, this triangle is a right triangle, so this angle here is a right angle. Okay, how can I find the length of this side here? This angle is given, 45. This side is unknown. Hypotenuse is given, 20. And this side is also unknown. So remember, if we have two sides in a right triangle, we can easily find the third side by using the famous Pythagorean theorem. But in this particular example, we only have the hypotenuse. This side is not given, this side is not given. So it is kind of not impossible, but it is hard to find the length of this side. By the way, if you pay attention to this example, you will see that this triangle is 45, 45, 90, right? Okay, so it's 45, 45, 90. If you remember from previous grades in your previous geometries, there are some special rules in 45, 45, 90 triangles that you can easily relate legs to the hypotenuse. Okay, you can easily write down the Pythagorean here because if this one is 45, this angle is 45. Therefore, this triangle is going to be an isosceles triangle. It's an isosceles. So whatever this length is the same. So you can easily write down the Pythagorean theorem and find the value of x. But that's not what I'm going to do here. I'm going to use trigonometry. This is a very special case that I could use Pythagorean theorem to find the value of x. But what if this 45 was just 40? What if it was 38.7? Okay, then I couldn't use Pythagorean theorem. So trigonometry is a little bit more general than Pythagorean theorem. So I'm going to use Pythagorean theorem. I'm going to use trigonometry here. So the hypotenuse is given, and you want to find this opposite side to this angle. If you go back to the trig ratios, only one of them relates opposite to hypotenuse. Opposite to hypotenuse. So which trig ratio relates opposite to hypotenuse? It is sine ratio. So I have to work with sine here. Sine of 45 degrees equals opposite over hypotenuse. So sine of 45 equals, opposite is given by x. We are going to find it. That's the height of the tree. And the hypotenuse is given by 20. This is a rational equation, so I can cross product. X equals 20 times sine of 45. Alright, so now here you can use a calculator to find the value of x. So you can use a calculator to see what is sine of 45, and then multiply that number by 20, and that will be the height of this tree. In later videos, I will tell you about the important and special angles. So this 45 is one of the special angles that you have to memorize the trig ratios of this angle. So we have some certain angles that you need to memorize the trig ratios. Like those angles are 30, 45, 60, 120, 270. These angles are called certain special angles. You will memorize in the later videos, but for now, I'm just going to use a calculator for sine of 45. So it's 20 times, if you use a calculator for now, you will see that sine of 45 is given by root 2 over 2. And if you multiply these numbers, the answer is 10 root 2, which is about 14. Okay, not exactly, but it is about 14. So the height of this tree is about 14 units, whatever this unit over here is. Okay, and that's it.